All right, so a brief overview of covalent bonding, hopefully to mirror what I did with ionic bonding. Covalent bonding is when electrons are shared, right? Ionic bonding was when electrons were transferred. This happens when atoms have similar electronegativities. Oh, that's really ugly. Let's try that again. A little bit less ugly. So if they're going to have similar electronegativities, they're going to be near one another on the periodic table. And realistically speaking, they're going to be my nonmetals, right? So these guys here. In covalent bonding, we've got a nonmetal with a nonmetal, right? Because they have to have similar electronegativities. And all we're going to use is prefixes. We've got mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, right? 1 through 10 correspondingly. Rather, respectively, not necessarily correspondingly. So from here, how do you write a formula, right? If you're giving something like hexaphosphorus, monoxide, right? This prefix tells you how many of these you have. This prefix tells you how many of these you have. So for phosphorus, I have 6, and for oxygen, I have 1. Right, going the other direction, if you had something like S2O, it's going to be disulfur monoxide. Notice we're changing the ending to IDE, just like we did with our ionic compounds. Couple of tricks, right? If you have something like this, that is carbon monoxide, we do not put the mono prefix before the first element. So it would never be monocarbon monoxide. This is just not done. The other thing that we said we had to watch out for were double AO or double OO, but double I was fine. Right, so this would become tetroxide. This would become monoxide. And this stays exactly as it is. Triiodide. There we go. Right, so this double vowel can't happen, this double vowel can't happen, but our double vowels with our I's are fine. And that's really it when it comes to naming covalent compounds. I hope you found this useful.